Translate the statement into a confidence interval. Approximate the level of confidence in a survey of 600 adults in the country. 82% think teaching is one of the most important jobs in the country today. The survey's margin of error is 4%. So in the confidence interval, so they want us to find confidence interval, then they want us to approximate the level of confidence. Okay. A confidence interval for population proportion is given here, where p hat is the sample proportion and E is the margin of error. Okay, so we can see that p hat here, the sample proportion, is given to us there. Okay, and margin of error is here, it's 4%. We can see it's there. And so we have a p hat here. We find a q hat would be 1 minus p hat, or 1 minus 0.82 is 0.18. So you have our p hat, we have our q hat, and we have our margin of error. So now they ask us to work on finding the confidence interval. So we got to find the left endpoint of the confidence interval. Okay. So they subtract a margin of error from our p hat, which gives us 0.78. Okay. And then they want us to find that right endpoint. So there's the right endpoint there by adding margin of error to p hat. So that gives us 0.86 here. So you have 0.78 by subtracting and 0.86 from adding. So our confidence interval looks like this here. Then he asks us to verify that a normal distribution can be used by seeing that if n times p hat and n times q hat are greater than 5. So we multiply here. 600 times 0.82 is greater than 5. And 600 times 0.18, that's greater than 5. So it has the properties of a normal distribution. Okay? Because n times p hat and n times q hat are both greater than or equal to 5. So to approximate the level of the value of the level of confidence here, we can take this formula here and solve it, find the z-score, solve it for c sub z, the critical value of the standard normal distribution. So they solve this for z. So they solved it for z here. Now they can plug in because we have our p hat and our q hat. We have the margin of error and we have the n. So we plug in here to find the z-score. And there's our z-score here. So our z-score. So our z-score is right there. And if you remember, the z-score matches up with a particular probability here, or confidence interval here in this case. Okay. So we're looking for here the level of confidence for the interval. So you can to the area understand the normal curve between negative ZZ and the positive CZ. Okay. So we can use technology or we can use a normal distribution to find that area. Okay. Let's take a look at this again. for this problem here. So in this, we found our z-score. It's the area underneath the curve between negative z sub z and z. Use technology or standard normal table. Find the area. Okay. For the purpose of this solution, we use the technology to find the area. Okay. So what they do here is they find the area to the left. Okay. Of c of a negative c sub z, and area to the left of c sub z, and then they subtract it off, and you have the area in between. Another way of approaching it is using StatCrunch to get it done. So we can go into StatCrunch here. Since we know that it has the properties of a normal distribution, we can use a normal calculator here. We want in between. So our mean is 0. We're working with z-scores, so our mean is 0. Standard deviation is 1. And this side here, you might have negative 2.55. And on this side, I'm going to have a positive 2.55. And it compute, and it gives me the area in between. So you can see here, in their area, they have 0.9892, and I have here 0.989822.771. So there's your answer there for that problem. This is chapter 6, section 3, problem 31.